So today we're going to continue on with the review, looking at number 3 on the review sheet, and it is asking you to predict the products and balance this double replacement reaction between lead 2 nitrate and sodium chloride. So, first thing we need to do is take these two names of the compounds and put them into chemical formulas. So, lead 2 nitrate, this is back from chapter 3. We look up lead on the periodic table. It is Pb. That's for its symbol. Now we need the charges. So whenever we have ionic compounds, we need to know the charges so that we can do the crisscross method to figure out what the formula is going to look like. So the charge on lead is going to be a +2. That's why it's got a Roman numeral 2. And then for the nitrate portion, we would look that up on our polyatomic tables because ATE indicates that it's a polyatomic. It doesn't have the normal IDE ending that we see. Nitrate on the polyatomic table, we would get NO3, and the charge is -1. So, doing the crisscross method, this 2 would become a subscript on the NO3, and this 1 would become a subscript on the lead. So we have Pb1, NO3, we're going to put parentheses around that whole thing, and the 2 on the outside of the parentheses. So here's our first reactant chemical formula. So they said that we're reacting lead 2 nitrate with sodium chloride. So for sodium chloride, to figure out the chemical formula of that guy, we would find sodium on the periodic table, and it's Na. It's an alkali metal. It's in group 1, so that means it has a +1 charge. All alkali metals have a +1 charge in an ionic compound. Chloride is just the IDE version of chlorine. It's a halogen, so it's going to have a -1 charge. Now notice, looking at these, the charges cancel. +1 -1 equals 0. So we need just one of each in that ionic compound. So it'll be NaCl. It's one of each. Now, in the question itself, it told us it was a double replacement reaction. If we didn't already know that, we could figure it out because we have two compounds reacting together. And what's going to happen is they're going to switch partners. So the general scheme that we see with this is we get AB plus CD is equal to AD plus CD. A being the lead, NO3 being B, sodium being C, and then chlorine being D. Now remember, when we switch partners, the key is new partners, new subscripts. What that means is we're going to take the charges when we switch over here and figure out what the new chemical formula is going to be. We're not just going to take these subscripts, so this subscript on NO3, we're not just going to take that and bring it over. Okay? So let's look at who's switching with who. So we said A, lead, is going to switch and now be partners with D, chlorine. So A and D are going to be together. So over on this side, we're going to have Pb with the 2+, and it's going to be with the chlorine. And remember, chlorine had a -1 charge. Now C and B are going to be together, so we're going to have sodium and the NO3 together. So to figure out what those chemical formulas look like, we're going to do the crisscross method again. So this time lead has a 2+, that's going to become a subscript on chlorine, and then chlorine has a -1. What are you doing? Morning.
I got to show you your picture.
Oh, great.
Do I really want